Alright, this is the last formal lesson of your geometry career, which is on circles in the coordinate plane. After today, you'll be able to write the standard form of the equation of a circle, and by looking at that equation, you'll be able to find the center and its radius. So let's just start off with a review of what standard form looks like. I think you already should know at this point. The standard form of a line is ax plus by equals c. Standard form of a parabola, which I forgot, that's one of these guys that look like a U, is ax squared plus by plus c equals 0. These are both a review from algebra, which will come in handy next year when you take algebra 2. Now, the standard form of a circle is x minus h squared plus y minus k squared equals r squared. I know it looks kind of like gibberish and a bunch of letters, but once we explain it, go over it a couple times, I don't think you're going to have any problems finding that on your own. So let's kind of break it down. X and y are just a part of your formula. It's just going to always be the same, no matter what. This h and k, that's your center. So if your center is at 1, 4, you just plug in 1 and 4 for k. And obviously r would stand for your radius, so whatever your radius is, let's pretend it's 3, you would square it, so we put 9 there. Okay? We look at these examples right here, center 4, 3, hence why 4 is there, 3 goes there. Your radius is 3, 1, 2, 3, so r squared, 3 squared is 9. Same thing here, your center is 2, negative 1. Notice you plug in negative 1, you would have a y minus minus 1. How do you clean that up? 2 minuses really is a positive. Hence why they got that there. Your radius squared, 4 squared is 16. Okay, why does this work? Well, let's explain it. First, I'd probably jot this down. It's not in your notes, it's white it out. That is the standard form for an equation of a circle. But again, why does this work? Well, let's look. We start with the distance formula here. Remember, that's x2 minus x1 squared plus y2 minus y1 squared. Then they tell us to substitute in xy for x2, y2, and hk for x1, y1. So then that would look like I'm plugging in xy for x2, y2. So x minus h squared plus y minus k squared. And then they tell us to square both sides to get rid of the radical. So if I square this whole side, it just gets rid of it. So hence, this is why we are left with the standard form of our equation for a circle. Because no matter where you are in the circle, your radius is always the same. We've talked about that many times, that no matter where you draw your radius, it's still the same distance away from your center, hence why it's a version of the distance formula. That's all it is. So now let's put this into practice. Write the standard form of the equation of a circle. So we're given a center of 0, 4, and a radius of 3. So up here, I'm just going to write this real quick. Oops. Third time's a charm. I'm just plugging in x. What's my x coordinate? 0 squared plus y minus my y coordinate, which is 4 squared equals 3 squared. Now let's clean it up. Well, x minus 0 is just going to give me x, so I can just leave it as x squared plus y minus 4 squared. And then And what's 3 squared? 9. Try it again. X, here's my x coordinate, my y coordinate, and there's our r. So x minus negative 2 squared plus y minus 8 squared equals 4 squared. Minus minus turns to x plus 2 plus y minus 8 squared equals 16. Okay, let's see if we can do it without writing up 2 steps. So again, x minus our x coordinate squared plus y minus our y coordinate, but minus minus would be positive 6 squared, and then 11 squared is 121. And then lastly, let's just write this one out because it's kind of goofy. X minus our x coordinate squared, y minus our y coordinate squared equals our radius squared. Again, we have the double negative, which makes it positive. Same thing here, so I get a plus 4. And then think, 5 squared, the square root of 5 squared really means square root of 5 times square root of 5. And remember, you take the numbers inside times each other, so I get 25. And we all know that the square root of 25 is just simply 5. Pretty straightforward. Now we're going to take away what's given to us, and you're going to have to look on a graph and figure out your center and your radius on your own. It's fairly simple. It says write the standard equation for a circle in the diagram at right. So again, you need a center and a radius to write the standard form of the circle. So that's where I would start. What's your center at A? So I'm looking at this point here. Here's my circle A. I'm over 1, 2, 3, 4. Down 1, 2, 3, 4. So negative 4, negative 4. Now let's find our radius. So what I would do is I pick my center and go across until I hit my side. 1, 2. Radius of 2. Now plug it into our equation. X minus our x coordinate plus y minus our y coordinate equals our radius squared, so I get 4. Let's try it again with circle B. So here's my center. Negative 1 up 2. Now we can count our radius. Again, go from your center to kind of one of the directions, either go up, down, left, or right. And then just count over. So 1, 2, 3, 4 units. Now again, just plug it into the formula. X minus our x coordinate, which turns to positive. Y minus our y coordinate. And we square our radius. So 4 squared is 16. Alright, last one on this page is for C. First, again, find your center. 1, 2, 3, over, down, 1, 2, 3. Our radius, again, we're just counting, nothing too crazy. 1, 2, 3, lots of 3s here. So again, plug into our formula. It should be negative 3, excuse me. X minus 3 squared plus y minus minus turns to a positive 3 squared equals 9. Okay. Then we may try to make it more interesting because obviously if all we did all day was count, this wouldn't be a sophomore level class. So it says, write the standard equation of a circle given the center and passes through the given point. Okay, if I look over here, we needed 2 things. We needed the center and the radius. If I look over here, I'm given my center, but we need our radius. So I hope you're thinking, how am I going to find my radius? Well, when you're you're given 2 points, you should use the distance formula. So here's my center, and I'm given some random point on my circle. If I find the distance between my center and some random point, that will give me my radius. All right, so here we go. Distance formula. x2 minus x1 squared plus y2 minus y1 squared. I am going to make this my x2, y2 coordinate. Okay? So -6 minus -4 squared plus 5 minus -1 squared. Minus turns to a positive. So -2 squared plus negative turns to a positive plus 6 squared. 2 squared is 4. 6 squared is 36. For a grand total square root of 40. Well, there's our radius. We just found our radius to be square root of 40. Now I have both parts that I need. So our equation, x minus our x coordinate, so minus 4 will be plus 4 squared, plus y minus -1, which is plus 1 squared, equals, okay, remember we square our radius. If I'm squaring square root 40, I really just end up with 40. So really all we had to do there was use the distance formula to get our radius. Well, practice makes perfect, so let's do another one. Again, we're given our center and we need our radius. Same process as before. We use the distance formula. I'm going to make this my x2, y2 coordinate. So again, square root 5 minus my x coordinate, x1, y1 squared plus square root 8 minus 0 squared. Well, anything minus 0 is just itself. Now I have a square root of 5 squared, which we know is a square root of 25, which is just 5. Square root of 81 squared is a square root of 64, which we also know is 8. 5 plus 8 is 13. So our radius equals root 13. Now again, just plug into our formula. X minus our x coordinate, which is 0 squared, plus y minus our y coordinate, which is 0 squared, equals root 13 squared. Let's clean this up a bit. X minus 0 is just x squared. Y minus 0 is just y squared. And we know that root 13 squared is just simply 13. The next set of examples is just graphing a circle given the equation. Again, it's not too terribly difficult. I think it helps if you label the parts. So let's find our center. Remember, it's the opposite of the sign inside. So if I have x minus 2, my center would be a positive 2. Same with the y. I have a negative 3, and it's the opposite of that, so it should be positive 3. Remember, this is r squared. So what's the square root of 9 to get just our radius? Well, square root of 9, we all know, is just simply 3. So from here, I would plot our center, 2, 3, over 2, up 3. And then I would count 3 away in all 4 directions. I'd count 3 up, 1, 2, 3, put a dot. 3 to the right, 1, 2, 3, put a dot. 3 down, 1, 2, 3, put a dot. 3 to the left, 1, And then I would try your very best to make a symmetric circle, which I will struggle greatly at. Something like that. And there is our circle. So again, on example 11, start with your center. So take the opposite of the sign, 7 minus 1, so it's a positive 1. I have a positive 5, so it's negative 5 for our y-coordinate. I remember this is r squared, so the square root of 4 is just 2. Again, plot your center, 1, negative 5. And then count 2 in all 4 directions. 2, 2, 2, and 2. And again, do your best to make that look like a circle. This next example will probably be the one that's the most difficult for you on your assignment. It's not that it's difficult, it's just a process. So let's think about what it's telling us. Write an equation of a circle with a diameter of ST. So I think it might help if you draw a picture. So there's my circle, and it has a diameter of ST. And then it gives us the coordinates of ST, so maybe we'll just label that so it helps you think of what you need to do. So if we think about the equation of a circle, we need a center and a radius. Now, can I find the center of my circle given a diameter? Well, I hope you're thinking it's the midpoint of that line, because it should be equal on both sides, right? Because I would have a radius here and a radius here, which would give me a full diameter. So if I find the midpoint of ST, I will find my center. So for those of you that kind of forgot, midpoint, add your x coordinates together, divide by 2, add your y coordinates together, divide by 2. Nice review before your final, since full year final, things like that will come back up again. So if we plug in, we add our x coordinates together, 0 plus 6 over 2. And then we add our y coordinates together, so 2 plus 10 over 2 and simplify. So I know that 0 plus 6 is 6, divided by 2 is simply 3. 2 plus 10 is 12, divided by 2 is 6. We just found our center. Not all we had to do there was the midpoint. So now, if I know my center is 3, 6, now all we're missing is the radius. So, just like before, how did we find our radius? Well, I took a point on my circle and found how far away it was from my center. So now I'm going to do the distance formula between my center and the point we're given. Well, since S has a 0 with it, I'm going to pick that point to use because my math will be a little simpler. So again, I'm doing the distance formula between my center and a point they gave us. So I'm going to have my center 3 minus 0, my x coordinate, plus now my y's, my center of my y, 6, minus 2, that's on S, squared. 3 minus 0 is simply just 3, 6 minus 2 is 4. Squaring these, I get 9 plus 16, which we all know is 25, and we know the square root of 25 is 5. So now that I have both parts, I can find and write the equation of my circle. So our equation of our circle, x minus our x coordinates squared plus y minus our y coordinates squared equals our radius squared. Well, 5 squared equals 25. you are. Nice job. Again, this will be the most difficult kind of problem on your homework. Simply find the midpoint of your circle by using the midpoint formula. Find the length of your radius by using the distance formula. You'll be good to go. And then our last problem for today says sketch the graphs of each equation. Find all points of intersection of the graphs. So here I have a circle, and this would just be a line. So let's start with the circle. I have a center at -2, 0, and a radius of 3. Plot that, -2, 0, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. There is my circle. Okay, I know this is kind of a stretch for some of us, but when we have a line, this is in slope intercept form. So I have a slope of -1/1 and an intercept of +1. So remember, you start at your y-intercept, which is our b value. The dot at 1. You remember your slopes rise over run. So down 1, over 1, down 1, over 1, down 1, over 1. Come the other way, up 1, over 1, up 1, over 1, and so forth. So this one worked out pretty nice. We have 2 points of intersection, right there and right here. So our intersection this one on the left would be over 2, up 3, so -2, 3. And this one on the right is over 1, up 0. So 1, 0. If something did not make sense, make sure you ask me, show me your notes so I can give you your homework.